All right, so this video is to start section 2 of chapter 6. We're actually going to do two different videos for this. But our objectives to start, we're going to talk about these statements. We did the converse of a conditional statement before, but now we're going to add in inverse and contrapositive. So if P then Q, right, is our general statement idea, right? If hypothesis, then conclusion, just like we had before. So maybe I'm saying if rectangle, then parallelogram, right? So that statement would be true. And then I look at the converse, if parallelogram, then, rectangle. That may or may not be, right? Because there are other kinds of parallelograms. There are rhombuses, right? There are squares, which would technically be a rectangle, so that one would have worked, but the rhombus doesn't. So we had those before. That's not new. And if something was true as the statement and the converse, that's when it got to be a biconditional, right? And then we would use that if and only if statement. But otherwise, we're going on to this new idea. You could have an inverse as well. So if not a rectangle, then not a parallelogram. Now, again, that's not true because, again, a rhombus is not a rectangle, and it's definitely a parallelogram. So the inverse and converse, in this case, both not true. The statement and contrapositive are going to be related as well, because if I flip it, if I say if not a parallelogram, then not a rectangle, that actually would be true, right? Because if it's not since a rectangle is a parallelogram, if it's not a parallelogram, it definitely could not be a rectangle, but it couldn't be a rhombus either. It couldn't be a square. But the statement is true, right? So the statement and contrapositive are both true. The converse and inverse in this case are both false. Any statement could always be true or false. But when I talk about this logically equivalent, we don't have to worry about the Venn diagram yet, so don't get too carried away trying to fill out your notes. But when I say logically equivalent, the contrapositive and the original statement always have to be the same, right? In this case, they were both true. That's always going to be true. If one's true, the other has to be true, right? If one's false, the other one would have to be false. So that's all that logically equivalent means, is that those things always match. At the same time, technically, these two things will always match. If the converse is false, then the inverse will also be false. If the converse was true, then the inverse would also be true. So it depends on the example. So we're just dealing with those statements right now. And so we have this example up here with runner/athlete. So if you're a runner, then you're an athlete. This is entirely dependent on an opinion. So some of these questions, the examples I used before for rectangle, parallelogram, those you don't really get a choice. You don't get an opinion on those. But some people would say that runners are athletes. Some people would not, right? So I'm going to say that runners are athletes because I'm not prepared to argue that Usain Bolt, the fastest man on the planet, is not an athlete. But you can actually have a different opinion on some of the questions that we have. So whether you say this is true or false is not actually that big of a deal. But you do need to be able to write your converse if athlete, then runner, which I would actually say is a false statement. Because for me, I'm thinking about maybe you're a bull rider. I think that's an athlete, and they don't necessarily run or have to run. So, and a NASCAR driver. You could call them an athlete. It depends on the person, though. Some people do not call them athletes, right? I'm an athlete. I'm a golfer. And some of us don't, right? Some of us don't run for sure. So it depends on your own opinion. But in my case, I would say that the statement's true, the converse is false. So that means that when I write my inverse, so the inverse is when I say if not a runner, then not an athlete. That better also be false, right? And I do feel that that is false, right? Because if you're not a runner, if you don't run very much, that doesn't mean you're not an athlete. Maybe your sport just doesn't really require you to run, right? If you play pool, right, you're a world champion at something like that. Like some people might still consider you an athlete, but it depends on the context. Again, you can have a different answer than me, but I know for certain that my contrapositive was going to have to be true because the statement and contrapositive are always logically equivalent. But I need to write that contrapositive if not an athlete, then definitely not a runner. So I do agree with that statement, since if you are not an athlete, there's a good chance you're probably not going to run, right? Not going to be a runner. So again, it doesn't really matter what your opinion is. You might have thought all of these things were true, or maybe you thought that the original statement was false when I thought it was true. It's up to you, right? But if you decide after saying a statement is true that the contrapositive might be false, that's when you know that you have kind of a hole in your argument. That's how you know that your logic might be flawed. So statement and contrapositive should always both be true. The converse and inverse should always match as well, right? I shouldn't have said they should both be true, but always statement contrapositive match, converse inverse match. So that's all you have to do on that worksheet is go through and write statements as converse statements, inverse, and contrapositives, and then decide in each case, is it true or false? But your statement and contrapositive should always match, and your converse and inverse should always match. Shouldn't be that tough to do.